Good morning and good evening. So, friends, we're discussing about CRISP MLQ methodology, right? And as you can see here, the CRISP MLQ methodology has 6 phases, and we started with the first stage, business and understanding. Then we have data pre-processing stage, and as I said, in the entire CRISP MLQ methodology, the 6 phases that we're talking about, majority of the effort that we put in from the hands-on perspective will be in this stage. From a hands-on perspective, when I say hands-on, you'll write code, Python code, right? So that majority of the effort comes in this stage. Okay, of course, you'll also have EDA in this. So you'll have to try and connect to the sources, get the data, perform the preliminary analysis, and then you also have to perform some pre-processing things, right? Pre-processing steps. So all this is hands-on. And when I say hands-on, it is not blindly typing the program. It has to be very, very smart here, because what is business requirement and how our data is positioned is very, very important. So whatever challenges that we are seeing, right, those actually become challenges when we meet the business context. Okay, and when I say business context, it also depends on your software and hardware that are being used. Okay, so combine all these things, you should be able to subjectively take a decision on whether a specific scenario is a challenge for proceeding further, or is it a specific scenario which we have to embed into the system, right? So it has to be very, very subjectively taken a call on. For example, um, okay, so let me talk about two companies, company A and company B. Okay, there are two companies. One company, A, let's say, is like a right big established company. Okay, I'll say Amazon. Okay, just for example. And there is another company which is a startup, okay, a new company. On a daily basis, how much data do you think Amazon is processing? Any
I mean,
guesses?
should be used. I mean, because it's a big company and a lot of transactions and all these things will be happening with respect to that, right? So it will be used data.
Correct. There are stats given by a lot of researchers, and it says that in 1 minute, that is 60 seconds, there are close to 1,000 to 2,000 transactions happening on Amazon platform worldwide. Okay, so just 1 minute, we are looking at 1,000 to 2,000 transactions. Probably on a day, regular days it is 1,000. On some kind of offers day, we'll have around 2,000. Right, so that is again, I don't remember. The stats are very, very old stats. It might have increased a lot. So if you're talking about 1,000 transactions per minute, we can try and see how much data that Amazon is generating, isn't it? And people have to log in. Not everybody is going to purchase. People do a lot of research, moving from one page to another page, reading their right content on the web pages. There could be videos on the web page. Product description would be there. Some people might go ahead and purchase the product. So financial transactions are happening. Some people log into the website and write reviews. So a lot of right transactions are happening in that 1 minute. We're talking about one day, 24 hours, right? So humongous data is getting generated. So let us assume that it is 1,000 GB, okay, or maybe I'll say 100. Okay, let's assume 100 GB per day. Now the startup, let's consider again an e-commerce company itself. Okay, very new e-commerce company. this new company probably will not see so many transactions. Of course, there will be no customers as well, right? Not too many customers will be associated with this company. So let us assume that this company has recently started and they probably have 100 MB of transactions happening per day. New company, right? We cannot imagine more than that. Now, can you imagine the infrastructure that both of these companies require? Yeah. In order to process 100 MB, I can probably use a very regular VM or regular server if I talk about on-prem, which may have maybe 16 GB memory or even 8 GB memory might be good enough. It's just 100 MB, right? From a storage perspective, if I can have, let's say, 10 terabyte storage, good enough, right? It is good enough to solve the problem for at least, right, 5 years to 6 years. No problem at all. 10 TB I'm talking about. But if I talk about same scenario here, do you think this could be sufficient? Or if I say 16 GB memory with decent server, right? Maybe high configuration servers or even decent server like 30i core processor. I don't know if 30i is there, but yeah, somewhere around that processor speed, if we have, I think it is good enough for solving the problem, right? Whatever the problems that we might get, we will be able to process this data. But can I use the same system here? The answer is no. The organization is well established and they have humongous amount of data that needs to be processed. So definitely this configuration would not be sufficient, right? So Amazon will have something called as big data challenge. Okay, big data problem. So what they do, they design their infrastructure in such a way that it is scalable. So they generally go with something called as distributed frameworks, big data. Okay, when we say distributed framework, we are talking about multiple servers interconnected. Like this, we have multiple servers. All of them are interconnected. And right, internally, they do the communication. But for the end user or for the process that or the task that we have, we will expose this as a single big supercomputer. Okay. So it's like we all have our own laptops or systems, right? Four of us. Now, how about combining all of them, interconnecting them? Internally, somehow they right, we establish connection and we combine the strength of the four laptops and then say, hey, we have one single computer. So it contains now 4 into storage device, right? 4 into the disk size, whatever the disk size that we have, 4 into memory, and 4 processors, right? So this way we will have multiple right systems capacity. That's called as distributed framework logic. But it is distributed framework. Okay, this virtual system, which is the capacity, which basically has the capacity of multiple nodes, will have a software called as Hadoop. I'm not sure if you have heard about Hadoop. If you have not heard about it, that's an operating system which basically runs on this distributed environment on cluster. All right, and it is open source. So this is basically how the big data challenges can be addressed. If I have to increase the capacity of this machine, what I do, I add more machines to it, plug and play, simple. So I will never have a big data challenge if I have a scalable hardware, right? And then I'll also use systems like Spark, I mean software systems like Spark, Then we have something like um, Zookeeper, right? Kubernetes. All these are software specifically designed to achieve certain tasks. Spark would be one thing that you should be looking at, which is basically like Python. We use Python library to deal with Spark. So that library is called as PySpark, which allows us to process the data. But this data, which is actually given, is distributed onto multiple systems. So what happens is this data is partitioned like this, and then each partition is stored in one single machine. Okay, that's the architecture that we have in Hadoop. And so data will be sitting here, 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 and here, for example. Internally, system knows that this is one single file which contains a lot of data, but that data got split into multiple, right, blocks, and then it's stored in different machines. If I want to process that, I will use specific tools. Like MapReduce is one such uh, framework, which is part of Hadoop. It's a component of Hadoop which allows us to process the data. But people started leveraging PySpark or Spark for processing this kind of data, which is partitioned and stored in different machines. Okay, so logically, we try to map all these blocks once again, and then that gives us the complete data. And once we have created this projection, which is called as RDD, we try to manipulate that particular data or process that data using Spark. Okay, in memory we store. Okay, so this is what I'm trying to explain is one, of course, I was trying to give you an overview of how your distributed environment works. But the most important thing that you need to understand is we have solutions for every problem. You need to first understand that, hey, this is a problem in our given scenario, and then try to apply an appropriate solution there. All right. So it will be very, very subjective when we talk about data pre-processing stage. And this subjectivity comes when we align the problems with the business scenarios that we are dealing with. Okay. So that's one thing that you need to understand. And then yesterday we were discussing about the model building strategy, unsupervised and supervised strategies. We have unlabeled data for unsupervised learning, whereas we have labeled data for supervised learning. When we talk about unlabeled data, we will have only X, whereas labeled data will contain X as well as Y, the target, explicitly in our data set. Again, that is simply because of the problem statement that we are trying to process. That defines whether this column is a target or not. Okay, we'll have the same data, but if my business requirement does not focus on any specific variable, then I cannot declare that as a target, right? That also becomes one of the feature. So that's purely depending on what we have to solve. Based on that, we can define label data or historical input data in our historical data. All right. Next, when we talk about the target or the label, we need to see whether that label is numeric or non-numeric. And we have to use an appropriate algorithm for trying to predict or estimate that label. So here, if the output is numeric, if the target, this column is numeric, then we will have to apply an algorithm which gives us that numeric outcome. These algorithms are called as regressors. And if my output is non-numeric, then we have to choose an algorithm which is having the capability to give non-numeric outcome. These are called as classifiers. So regressors, numeric outcome, classifiers, non-numeric outcome. We have linear regression, logistic regression. As an examples, we have ordinal regression, non-polynomial regression, we have multinomial regression, we have um, uh, what is that, negative binomial regression, right? So there are a lot of such regression techniques that we can use. These are all statistical based models. Okay, and here in classifiers, we have an alternate methods. That means we don't directly use a statistical equation. Okay, these are some simple and convenient methods which help us to define the logic which explains the relation between x and y. For example, in KNN, we use distance logic. So if I talk about these points, okay, let me say, I'll erase this. Let's say I have data scattered like this, and the best example we can talk about is I have a scenario where I want to understand whether the student passes or fails. Okay, binary case, or maybe a person has cancer, no cancer, or a customer purchases the product or not purchases the product. Okay, so on and so forth. So we are talking about a binary problem. So we will have yes, no, true, false, right? Like this. Cancer, no cancer. Yep, pass, fail, etc. So let's say in the scenario, I'm taking two variables. Let's say this variable is speaking about age. Okay. If I'm talking about, let's say, the student's scenario, right? Student's age is one of the variable, let's say x1. Then we'll also talk about preparation time. Okay, preparation time. This becomes my x2. And what is my target? I will have target, which is student passing or failing, non-numeric outcome. Okay, pass or fail. This is what we're going to look at. Okay, binary outcome, non-numeric. Now, let's say when I looked into the first record or one of the records, this is one of the records, I'll call this as A. There are a lot of historical data, okay? All these are my old students. Now let's say this is another student called B. And I have one more student called C. Okay. Now looking at this image, can you tell me among the three students, which two students are similar to them, similar to each other? Very simple. I have three students, A, B, C. Which pair of students are similar to each other? Is A similar to B, or B similar to C, or A similar to C? What do you think? Who is similar to whom?
A and B.
Very simple, right? A and B are similar. Why are they similar?
They are close to each other.
Very good. Close to each other means how do we interpret that? Right? So let's see that. So when we talk about A and B being close to each other in this X and Y plane, because it's a two-dimensional, we are able to view it, right? And because of this closeness, we are saying they are similar. That means they are neighbors to each other, right? That basically means on the x-axis, the distance between A and B is less. What does that basically mean? Is let's assume that this A is 25 years old student, or maybe I'll say 21 years old, whereas B is 22 years old. Whereas C here, you can see, is a little far away. And I will assume that this guy is, this person C is 30 years old. So in age, A and B are very close to each other. They have similar age compared to C, right? Likewise, if I talk about the preparation time, in the preparation time also you can see A probably has prepared for 5 hours, B is prepared for 6 hours, C is prepared for, let's say, 7 hours. Again, if you look at the preparation time aspect, A and B are close, right? 1 hour difference, right? But you may say that, hey, B and C are also close. Fine, but B and C, from preparation time, they are same. What about the age? They are not, right? So considering all the factors, in this case, I have only two factors, but if I have more factors also, more dimensions as well, considering the similarity of multiple observations or multiple students in this case, on all these dimensions, we will be able to identify which record is similar to which record. Okay, in this case, which students, right? Which pair of students are close or which group of students are close to each other. Now, let's say I have a new student coming in the picture. There's a completely new student who has joined the organization. Okay, this red dot I'm drawing here. But I want to see this red dot X, will this person pass or fail? How do I know? What can you say? Will this new student X pass the exam or fail the exam? I want you to predict. What can you say? Fail. Okay. On what basis are you saying that this person is going to fail? Reasoning is important. Yes, Ambit and Anil, you both have to be answering this question. You guys already are aware of ML concepts.
Yes, sir. Yeah.
Not able to tell? Forgot?
Sir, can you repeat me once the question?
Yeah. Samit, what about you?
Can you repeat the question again?
The red dot in this X and Y plane, which is X, I want you to predict and tell me whether the student will pass the exam or fail the exam.
Sir, pass, sir.
Okay, on what basis you are saying pass?
Like we can see in y-axis like time. So for 5 hours, like compared to overall here, like he spent like X spent more time on study.
Hmm.
So obviously he's supposed to pass.
What about the age? You're not talking about age. Why are you not considering age? Why only study hours? Probably the person is a little old, and because of that, The person has to study more to remember things, maybe. See, you will not be able to decide whether the student will pass the exam or fail the exam. No, in this given scenario, you will not be able to know that because I have not given you that historical information here. I just given you a scenario that, yeah, this is what we are looking at. But if I give you complete data, then you will be able to tell. How? If you look at this diagram, what you will observe is this person X, who is he closer to? Is this person close to A? Is this person close to B? Or is this person close to C? What do you say?
Close to C's.
X is more close to C. That's right. From a diagram, from the age and the preparation time also, if you see, close to 7 hours and close to 30 years, right? So from that perspective, the features of X, right, we can say X is more closer to C. So given this information, you will have to go back to the historical data and see whether your C is pass or fail. Okay, this is A, this is B, this is C. I'll go to the historical data and I will know whether C passed the exam or failed the exam. Maybe C is failed. Maybe, I'm just giving you a scenario. This person C has failed the exam, maybe. That means X also will have more chances of failing the exam. Why? Because X and C are close to each other. Right? Their features are close to each other. That means their outcome also will be similar compared to A and B. Making sense?
Yes, sir. Yeah.
This is what KNN is all about, right? Estimating or predicting or classifying based on similarity logic. Okay, very, very simple. I don't use any mathematical or statistical equation here. Right? I'm not using that. Y is equals to f of x is a statistical equation. I'm not using that at all. What I'm using is a very common sense driven logic which defines the similarity. And how do I measure similarity here? How can I say that they are similar? By measuring what is this? What is this red lines that I'm drawing here?
I think by comparing the things, we are actually bringing the similarity, something like that.
Distance.
It is
Okay.
distance. Okay, that's the distance. I was trying to represent the distance here. So if the distance is less physically between two different records, I mean two different elements, if you see distance is less, that means they are more similar. Right? So the quantification happens based on distance logic here. That is what KNN algorithm is all about. KNN, what is the full form?
K nearest neighbors.
The name itself says nearest neighbor, right? But we don't take one nearest neighbor because it could be exceptional case. We don't know. We want to ensure that, right, we get more confidence when we are trying to estimate an outcome for a value. When I say outcome, I'm talking about target. Value is nothing but the record input. So when we are trying to estimate the outcome or classify a record, we want to be very, very sure. We want to have more confidence in estimation. So we don't take one record which is very close, but we take group of records which are close to each other. Right? And if I have, let's say, this was X, right? If I have more data points here and all of them are failure candidates, then I will also have confidence in saying that X also will fail. Right? So that builds us confidence. So that is what K nearest neighbor is all about. That logic is, the implementation is based on distance logic. Okay. And this algorithm has the capacity to tell us what could be the outcome or what could be the class for a given record, which is non-numeric. The class is non-numeric. For example, in this case, we said pass or fail, right? But these distance logics can also be used to calculate numeric outcome. We have k nearest neighbor classifier. We have k nearest neighbor regressor also. Same logic works, but there we are talking about value which is numerically represented. Similarly, we have knife Bayes algorithm. How does knife Bayes algorithm work? What is the logic behind the scenes of knife Bayes? Here we are using distance as a logic. What do we use for knife Bayes? Yeah. Bayesian classifier, knife Bayes or Bayes theorem. What is Bayes theorem?
It's totally probability based.
Yes, knife Bayes is probability based concept. Okay. And in the probability, we are specifically talking about a variant called conditional probability. Okay, what does conditional probability means? Rather than just considering the plain probability, we'll put a condition and then say, given the condition, what is the probability? What is the chance of student passing the exam? Okay, so I have historical data. I will take all your results from past exams, right? And I will see how many times you passed, how many times you failed. Okay, let's assume I'm taking, assume 100 records, that means 100 data points or 100 exams that you have written already. And out of all those exams, I am looking at how many times you passed and how many times you failed. Okay, out of 100, let's assume that you have passed 95 times, 5 times you failed. So given this information, what is the probability of failure? What is the chance that you fail the exam now if you're writing a new exam? So simple probability, right? It's 5%. The chance that you have that you will fail the exam is 5%. That means 95% chances there that you pass. Isn't it? From the historical data, I'm talking about you whether passing the exam or failing the exam. But let's purely see the scenario. I will conduct an exam now. Okay? Any subject, let's say Python. If I conduct the exam in Python now, the outcome will be depending on your past exams. If you're writing an exam now, that's the outcome of that exam. Anyhow, depend on your previous exams. What do you say? Or what do you have to say? Making sense, my question, or not? It depends, okay? Okay, so Krishna says it depends. What about others? Sambit, what do you say? Sambit, you there?
Yeah.
Okay, I'm audible, right? Yeah. So simple question, Sambit. You have written your exams, your academics, for example, graduation, if you have done post-graduation, let's assume that. post-graduation, graduation, and right, primary, higher primary, all those exams are considered. So I have 100 exam results of you writing different exams. And what I'm assuming that you have failed 5 exams out of 100 exams that you have written. This is specific to you. Now I'm conducting an exam on, let's say, generative AI subject. What is the chance that you will pass the exam?
Sir, without historical data, when he failed in the 5 exams, he cannot predict, sir. First thing is that maybe he would have prepared well for this thing, right? So that depends on whether the information why he failed in the 5 exams which we have, then we can predict it. So that's what I think.
Very good. That's a very perfectly put answer. Right? So the answer specific to my question will
95%.
be, sorry, go ahead.
95% pass percentage.
So
The
you are
chances,
saying
the
that
chances, yeah.
that's what. So if I'm saying you will have to write an exam now on Gen AI subject, you are saying that based on the historical data, you will have only 95% chance of passing that exam, is it? That's what you're saying?
Yeah.
Okay. I'm really surprised you guys are saying that.
No.
How does your previous exams, previous exam results, is affecting the exam that you are writing now? That too, I'm
That's what
giving
I
you a
mean.
subject, generative
Correct,
AI
sir.
subject.
Yeah.
That's what, sir. I mean, like it all depends upon the preparation. I mean,
Yes,
we
sir.
cannot say that he will pass the exam or not. So
Correct.
it's upon
Yeah. Krishna has given the right answer. That's right. There is nothing to do for your new exam from the historical exam. I'm only talking about result, right? I'm not talking about any other columns here. So only result if I consider, then the new exam has nothing to do with this specific information. There might be other factors that we have to look at. What are those factors? Preparation time, right? Your IQ, the material that I give, right? The training that you're getting, so on and so forth, isn't it? So there will be other factors that needs to be looked in when we are writing this exam, not your historical results data. Right? So if I only talk about one column, which is the Y column, I'll not be able to guess or estimate the new value. No. What I need is other factors which are influencing that result. Right? So base estimate, yes, I can say, or given this scenario, if I have to only calculate probability, then yes, probability is 95% pass. That's okay. That's because of your historical data. But the problem is it is not related. Okay. So what we do now is, what is the probability of Y given that student is preparing for 5 hours, let's assume. So I'm giving a condition there, right? What is that condition? I'm saying student is preparing for 5 hours. Now tell me what is the chance. Rather than just looking into the historical data blindly, I'm putting a condition. Right? This is very similar to y is equals to mx plus c. If I don't have x, y is equals to c. Right? This is y-intercept, which is nothing but average. Right? That is what we are looking at when we take only the results. Y. But what I'm saying, X also influences it. So we say X is also included in the equation. But the outcome that we are looking at is not numeric in this case, right? This is a non-numeric case. So I cannot use y is equals to mx plus c, mathematical equation which gives us value on a line, right? Continuous value, numeric value. That cannot be done in this case. So what we do is we will put conditional probability logic. Okay, so given the student is preparing for 5 hours, so we'll write like this: probability of class given the condition. Okay, so I'll write like this: what is the probability of the student passing the exam given preparation time? Yeah, so this is your base theorem. So what we do here is we look at the historical data first. Okay, in the historical data, I would see what is the probability of pass. That's 95%. We got it, right? From the historical data, what is the overall probability of pass? But this is only a small information, right? That means this tells us the student has higher probability of passing the exams. Regularly, the student passes the exam, 95% means. Right? This is historical data. Similarly, I will see how many students have actually prepared for 5 hours. Probability of 5 at this condition. Out of all the students in the historical scenario, I mean, all the exams that the student has written, how many times the student just prepared for 5 hours? That is also something I try to retrieve. Then in the numerator, this is very important. We will try and see how many times student has spent 5 hours and passed the exam. So I'll look into all the past cases first, not entire data. Okay, out of 100 exams, 95 times student passed, right? So I'll only look into this case. And in this case, I'm trying to observe how many times student has passed or failed. Okay. Sorry, how many times the student has spent 5 hours. My bad. So I'm specifically digging into this case, 5 hours case. Okay. So this is Bayesian theorem formula. This is called as posterior probability. Terminology is posterior probability. This is called as data prior. This is called as class prior. This one is data likelihood given class. So given class is given already in the historical data. What is the likelihood of that particular data that we are putting as a condition has occurred? So how many times student has passed if student has spent 5 hours? That's what we are trying to extract information from this point. This is likelihood, data likelihood. Okay, so this is the conditional probability formula which is used in Bayesian theorem. We call this as Bayes formula, Bayes formula, or Bayesian classifier model. Okay, so we are using simple probability logic to understand the probability for a non-numeric case. Okay, how many of you remember this Bayes logic? Among you two, Anil and Sambit.
Yes, sir.
Remember?
Yeah.
Kind of. What is a hyperparameter? Okay, question only to Sambit and Anil. If you are claiming that you remember Bayes, let me check.
I don't have that.
You forgot, huh? Okay, what is a hyperparameter? Anil, to you, question. What is a hyperparameter in Bayesian classifier?
hyperparameter tuning is nothing but, let's say if we get accuracy 80%, so just we are tuning the algorithm to get more accuracy by using hyperparameter tuning.
Yeah, my question is, in knife-based algorithm, what is that parameter which which you will tune?
Oh, so I'm not sure.
Okay,
Long
what
back,
is the
I
hyperparameter that we use in Canon? No? Forgot?
no ideas. I forgot that.
In Canon, K is the hyperparameter, right? We have to find out what is the best K. How many neighbors should I consider for getting the appropriate predictions? So we experiment with different values of K, isn't it?
Yes, sir. Yeah.
So K becomes hyperparameter, distance metric becomes hyperparameter, Euclidean distance could be used, Manhattan distance could be used, cosine distance can be used.
Distance also hyperparameter, like Euclidean distance, Manhattan,
Yes.
and
Yes,
cosine.
absolutely. That's right.
Yeah, I got it.
And in Naive-Bayes, we have something called as Laplacian smoothing. Smoothing parameter. Laplace, remember?
Yes, sir. Yeah.
What should be the value of Laplace? Or what should we not put as the value for Laplace? Okay, you'll have to read. Ensure that your basics are very strong. Laplacian smoothing will solve a problem called as zero probability. Okay, read about it. We'll not discuss that here, but you'll have to read. Okay, and Laplacian is again represented as K, or in Python it is represented as alpha. And Laplacian smoothing cannot be equal to 0. It has to be anything but 0. Any new positive integer is what we have. Okay. Now coming to the third model, decision tree. Decision tree. What can we say about decision tree? What do you remember when we say decision trees? Sambit and Anil. Krishna, you'll have to just try to grab the certain keywords. It might look completely new to you, but yeah, just stay with us.
A tree-based.
Okay, tree-based. What does that tree-based algorithm means? Here we are saying distance. Here we are saying probability. So what do you mean by distance? Sorry, what do you mean by tree-based? My bad. What logic are we using here? It's a rule-based algorithm. How do we get these rules? We get rules by creating a flow chart. Your tree-based diagram or tree-based model is nothing but we are constructing a flow chart. And when we see a flow chart, we will be able to define different paths like this, right? So each path is a rule. All right. So decision trees are rule-based algorithms, and those rules are constructed by constructing flow diagrams from the historical data. And the objective of that flow diagrams is to get the target variable as the end result. Okay, so that is decision trees. And what is one very important point that we should remember with respect to decision trees? The most important thing in decision trees that we need to remember when we are using decision tree for model building. One aspect that you need to remember, never forget about decision tree. What is that?
So pruning.
Why pruning?
So I think like when to cut the tree and when to grow the tree, I think. So,
No, that is the definition of tree pruning, but why pruning? Why you have to use pruning? What happens if I use pruning? Okay, what does pruning mean?
pruning.
What does pruning means? I'm coming from right the basics. So pruning, what does pruning means? Krishna, are you familiar with gardening? Do you do gardening?
No, sir, but I have an idea that pruning means removing the weeds or something like that.
Yes, removing unwanted branches, removing the wastages, right? Unwanted things. So pruning basically means in decision tree, we want to cut the unwanted branches. Okay. So that means we are putting conditions while the tree is growing. Okay. Conditions, I mean restrictions based, controlled growth of the tree. Why we want to do that? Why we want to control the growth? So that we get desired output. Isn't it? So pruning in decision trees will help us to ensure overfitting does not happen. So what is that one very important thing that you should never forget about practically implementing decision trees? Overfitting problem. Decision trees are the algorithms which are prone to overfit. Remember yesterday we discussed about the metrics and I told the difference between overfitting, underfitting and right fit. Yesterday we talked about this, right? So decision trees are the algorithms which are most prone to overfit condition. To control that, we do hyperparameter optimization or hyperparameter tuning. That is nothing but pruning in decision tree scenario. Okay. Now, we talked about models which are specifically used for predicting non-numeric outcome. KNN distance based, naive based probability based, decision tree rules based. Okay. And we also have logistic regression, which is also used for classification purpose. Logistic regression is used for predicting non-numeric outcome. And I was talking about accuracy, right? So for classification methods where you have non-numeric outcome, we cannot directly use error calculation. So what we do, we use comparison technique and then we will calculate accuracy. This basically is done using something called as cross table. Okay, it's called as cross table, wherein we put actual values at one side, predicted values on column. So rows and columns, we will put the categories of actual values, pass fail in this case, and predicted also we will get pass or fail scenario, right? So we will basically take these two conditions, pass, fail. Here also I'll say pass, fail. And then we do a quick comparison. Pass and pass means true, fail and fail means true. Pass and fail means our prediction is wrong. Right? We failed in predicting the result correctly. Here also, if a student is failing but the predicted value says pass, that means this is also failure in our predictions. Right? Wrong predictions. So if I have 100 predictions out of 100, that means all the total predictions, which basically talks about true positive plus true negative. That means this case, both false, right? So total, I'll say all the values considered, which basically is nothing but total. In the total predictions that we did, out of 100 predictions, if I'm talking about, how many times the model was correctly predicted? So sum of true predictions. This gives us accuracy. Okay, but when we talk about a binary comparison here, this cross table becomes binary cross table or binary cross entropy, we call it as, and we get a specific name for binary case, which is called as confusion matrix. If my comparison is a binary case, then that comparison, this table that you're seeing is, or this matrix that you're seeing is called as confusion matrix. Okay, and in confusion matrix, what all different metrics we will look at? Anil and Sambit. What other metrics can we see in confusion matrix? Not just accuracy. Of course, accuracy is there and error is there, right? So if I talk about true cases, then it is accuracy. If I talk about false cases, then this is error, right? But what else we can see or what else we use from this confusion matrix? Anil, come on. Confusion matrix. What other things we will see?
I need to look once. A long back, I looked at one.
You're preparing for interviews. These are foundations, guys. Don't forget them. We will look at sensitivity.
Oh, precision recall. Yeah, this one.
Yes, sensitivity is also called as recall, or it is also called as hit rate or true positive rate. We also have specificity. This is nothing but true negative rate. Then we have precision. Precision talks about true cases, predicted true cases. We have F1 score, which is specificity by precision, right? The balance between precision and sensitivity. We have to carefully look at false negatives and false positives so that we can analyze the cost of misclassification. So many things are coming up. Yeah, we also have to look at the cutoff. What would be an ideal cutoff? And in order to get ideal cutoff, we will look at what diagram? we'll look at how do we know whether the cutoff value is appropriate cutoff or not? How will we know that?
0.5.
No, that is default cutoff. Yes. What is optimum cutoff? How do we know that? ROC, receiver operating characteristic, ROC curve. This will tell us what is the appropriate cutoff. Why? Because if I take cutoff as 35%, okay, let's say 35, that is 0.35. Then if I consider student marks in a school, the administrator decided that we will declare students as pass only if they score greater than 35, 36 or more. Okay. Then if we take a student marks, let's say one of the student has got 39 marks. Okay, student has got 39 marks. So what will be our predicted result here for this particular student, given the cutoff is 35? Is this student pass or fail?
Pass, sir.
Pass, right? Yes. So given this cutoff, the student is passed. But let's say we have another school. Okay, there's another school, and that school decided that the cutoff will be 40%. Now, in that case, what will be the predicted value for this 39 marks?
Fails.
So here we are saying that student failed. So same result, student is getting 39 marks, but in one case, we are saying the student failed. In another case, we are saying student is passed. So unless until we compare that with the actual value, I'll not know. Isn't it? Whether this cutoff is good, correct, or whether this cutoff is correct, I will only know when I compare the actual value with these predicted values. If the student is passed, in actual, if the student is actually passed, that means my 40% cutoff is not correct. I'll get more errors, I'll not get accuracy, right? So what I have to do, I have to adjust the cutoff. Okay, so choosing the right cutoff is also important, and that is done using ROC curve. Okay, I can go into the details of ROC curve, what we will have on x-axis, what we will have on y-axis, but I want you people to study that. We're not going into that depth of topics here. Okay, read about those things. All right, next, moving on. Whatever the algorithms that we are talking about, whether it is unsupervised, supervised, unsupervised regression or classification, whatever it is, we have to use the model evaluation techniques and try and compare if we get desired result. So this basically defines quality. Whatever the model that we built, right? We will be able to assess the quality of that particular model in predicting the general cases that are going to come. And this can be basically used, the metrics that we calculated here, right, for model will be used for comparing and seeing whether acceptable values are occurring or not. What does that basically mean is, when we are discussing about the business understanding standard, the first stage, business understanding right, concepts, here we will, after doing the preliminary discussions, here itself, once we define our specific objective that we will have to achieve, we will also gather some benchmarks. Okay, these benchmarks will be used for comparison in the later stage. For example, I will say that I want to improve or maximize student success rate. I'll say this is my objective. I'll say maximize students' success rate or pass percentage. That means I have to make sure that students are passing. More and more students are passing. Okay, but maximize students' success rate means if I have 100 students, all the 100 students should pass. Right? That's basically your maximum that you can achieve, isn't it? But maybe that practically is not achievable, right? We don't know. So if I have, let's say in a B school, only 80% pass percentage, I want to improve this 80%. Right? And I'm saying maximize. Maximize means 100%. But when will you accept? Do you really need 100%? May not be practically possible, right? So we will put a benchmark saying, after implementing strategies that we are going to define now by analyzing this data, we will basically achieve, or we have to achieve, at least another 10% improvement. That means we need to reach 90% pass percentage. Okay? So after implementing the strategies, if the students are right improving the success rate, that means out of 100, then let's say 92 people are passed, 92% of the students are passing, then I have achieved my set goal. Because my goal is to reach at least 90% success rate. So anything beyond that is acceptable, obviously, right? So this way we set benchmarks or success criteria in business understanding stage itself. So we will use those success criteria that we created, the benchmarks that we defined there, while we are evaluating the model. Now, what if I got a model which is 89% after developing the model and after implementing the strategies to address the pass percentage challenge? Let's assume that out of 100 students, 89 students passed. Did I meet my success criteria? Did I meet my benchmark? What is my benchmark set? So let's say I'm the university, okay, I'm coming to you and saying, hey, my students are not passing. I want to improve that pass percentage. Right? That is my problem. So what you do? You build a machine learning model, which helps you to predict whether the student is passing or failing. Now, if you know the student is failing, upfront if you know, then depending on the factors, the influence of factors on the outcome, you would basically treat, right? Say, for example, the student age is high and very, very senior person is there. So you cannot obviously change the age. So what you see, maybe preparation time I want to address. Given the pass percentage and the age, maybe the student has to spend more time. So what you do, you basically consider tweaking these input factors. That way, you will be able to ensure that failed student can pass, isn't it? So that's a strategy that we are implementing. So that is possible when you are able to predict whether the student is going to pass or fail in the first place, right? Being proactive. Now, when you built a model, you implemented all these strategies, but when you went back and checked for one of the exams that the students are writing after implementing the solution, you observed that students have scored 89 marks. 89% is passed. What is our success criteria that we defined? 90%. Okay, I'm saying my requirement is that I need at least 90% of the students to pass. That's what our understanding is. Okay. Now, based on your solutions, when we evaluated the model, you observed that only 90% students, 89% students are passed. Should I accept your solution? Is it acceptable? What happened, guys? Not able to understand the question?
But 90% is not, is not that great, right?
No, for a university which has only 80% pass percentage, don't you think 90% pass percentage is good? I'm the customer, okay? I'm the B school. In my business school, I have students overall who are only having 80% graduation rate.
Mm-hmm.
Out of 100 students, only 80% of the students always pass.
Okay.
Now, if I can make it 90%, don't you think that is an improvement?
Yeah.
To achieve
Yes.
that, it takes a lot of effort. Yeah, so given this, if your solution is helping that university, that B school, to achieve only 89% success rate or graduation rate, whereas my requirement is 90% graduation rate, should I consider your solution or not?
So actually 90% is good only.
You did not reach a 90%. This is what I'm asking. I'm asking that you have to give me a solution which ensures that at least 90% students graduate from my B school. Okay.
So, okay.
But when you developed a solution, you guys developed a solution. Okay. And you gave me recommendations. I implemented them. And when this year, when students are writing the exam, what we observed, 89% pass or graduation rate happened. That means from 80% last year, this year it is 89%. Is it an improvement or not?
Yes, sir. Improvement now.
But what is my requirement?
90.
Did you reach 90%?
No.
So should I accept your solution or not?
But not for 90%, no, sir.
1 mark, you fail. You cannot say that, hey, it is not far from pass percentage, right?
Yeah, then we should not accept.
It is not acceptable. This is what quality is all about. Crisp MLQ. Q stands for quality. Quality is measured based on these kind of assessments, comparisons only. So what should you do? What should you do now?
Retrains.
Not retrain. Training is already done.
Hyperparameter tunings.
Yes. What you're basically trying to do is you are trying to improve, tune your model. Okay, based on that, your model's tuning, you would basically be able to improve the accuracy of your model in pass and fail scenarios. And based on that information, the training requirement that you basically are providing, right, to the failed students will be more appropriately meeting the desired requirements. You want to specifically train a student who is definitely going to fail. And we also have to understand what is the reason of that failure, right? So when you tune your model, your equation changes, right? It will more appropriately identify the reasons for failure as well. Okay. So this process is called as tuning. Okay. You keep experimenting, you keep tuning until this benchmark is achieved. Okay, until it is achieved. So until then, what we do, we constantly try to improve our model. When it reaches 90%, at least 90%, that is when we apply it into the production scenario. Got it? We'll not directly take the model and apply it into the scenario, into the production case or live cases. Got it? We will try to simulate it on the historical data itself and then take the relationship information that we are extracting from the data to further enhance the model. Clear?
Yes, sir. Yeah, clear.
So we are talking about model building, model evaluation. But in these two, we will have a cyclic approach. We build the model, we will evaluate. But does it reach the required standards? Maybe not. So what we do? We tune the model, we adjust. Okay, we keep tuning it until it is giving us the desired result. Clear?
Yes, sir.
Now, once we reach a stage where we get the desired model, the best model, which gives us the desired result, this best model will be saved. Okay, the model will be saved. What does model saving means? You're writing a Python code. Okay, you have written a Python code. This Python code is what? .py. Right? .py file. So when I want to build the best model and give it to the customer environment, right? It has to be going and sitting in some other customer's environment, isn't it? Different hardware, because whatever experiment, the code that you're writing is developed in your local machine, isn't it? In your computer. But ultimately, the solution has to sit in what? Client's infra. In production environment. So that means I'll have to save the best model and give that best model to be executed in the customer's infrastructure, customer's environment. So what does saving of the best model actually imply? Are we giving the .py file to the customer? What do we give?
No, sir. After deployment, we'll give total to client.
What does that after? How do I deploy it? After deployment is fine, but how do I deploy it in the customer's environment in the first place? What does deployment basically means? We will give it as a module. Module again is nothing but a code, right? Saving the best model basically means the final equation that we get, right? If I talk about regression case, we get this equation. Okay? We write like this. So X is input factors, Y is what we read, and these coefficients, beta values that you're seeing, those are the coefficients which define the rate of change in Y given X. Saving the best model basically means we need to save these parameter values. Okay. In decision tree, saving a model basically means I need to save all the rules that we are generating. In knife based, saving the model basically means the likelihood, right, that we are able to calculate, the probability components that we are able to calculate, those probability components have to be saved. Right? In K and N, the K value we have to define. So what happens is when we save, right? Saved model basically means it contains these components. But how do we save? It's not .py file. We have functions or libraries like joblib or pickle, or there are other libraries, but these are very popular, pickle and library, joblib. We use these libraries like pandas libraries. We use these libraries to save the best model, right? Save the best model means save the components of those models that we are defining. And this gives us pickle files, for example, .pkl file. Okay, so you save this in a pickle format. Now this file is what we share to the customers. Remember the pickle file, Arun? Sorry, Anil? Saving the best
Yes,
model?
yes, sir. Whole models will be saving in pickle file or joblib. Yeah, we used to do, sir. I remember.
Yes. This is what we do, and we save this to the customer, not the Python code that we are developing, but the pickle file that we developed. This is for POC. Okay. So this pickle file goes and sits into the customer environment. Okay, one question. Where does security sit in, sir? Since the data is correct for all these, I do not see data is being protected right now. How company will protect their data sets in near future? Maybe. Okay. See what we are going to work with, right? Whatever the model that we are developing, we will be developing, yesterday I was talking about this, we will be developing it on a sample data. So this pickle file that we are going to develop, right, as I said, is a proof of concept. The proof of concept will be implemented on a sample data that will be given in a offline mode, or some restricted access will be given to sample data. Even if it is a database access that we get, they do not expose entire data to the consultants or data teams. They only expose a view or a temporary table, for example, right? Or physically we will get CSV file. Let's assume that we have 10,000 records. Okay, students data. If I'm talking about universities and student data, I might have 10,000 students information from last maybe 3 to 4 years. But if you see the university, do you think university is only having last 3 to 4 years of data? No, right? It probably is running from last 20 years. University is running from last 20 years. So what university do is they give restricted access to the data. They don't give entire access. That is one aspect to ensure that data is protected. The second one is any personal information, PI data, like students' phone numbers, email IDs, their addresses. Addresses still is okay. But right, anything which is personal, if we define that address is personal information, then we will also restrict that. We don't give the exact address. We give probably a representation of that address. So rather than students' phone number or email ID, right, we can use their student ID. This way, I'm masking their personal information. All right. And then what happens is the actual deployment. I want to talk about the actual deployment, but because of the time constraints, I probably will take it up tomorrow. What happens is the model that we have developed, right? Whatever the model that we developed, that model should get implemented in the customer's environment. Okay, this is, let's say, customer environment. Here I have only 10,000 records, but here maybe I have 100,000 records. Full data, maybe. This is only sample data, right? So whatever we did on these 10,000 records needs to be actually done here, right? So we develop these saved models. Whatever I did is only for POC, saying that, yeah, this is how we can predict, right? And we explain that to customers, saying that, hey, this is what we can do. And based on the information that we are extracting, strategy 1, strategy 2, strategy 3 can be implemented. Right? This is at a POC level. Now, in productionizing things, what we do, we take .py file, not pickle file. In productionizing, we will use .py file, and in the .py file, we have to write the program in such a way that it is modularized and everything is pipelined. Okay, pipelines. And we connect these pipelines so the data flows through them. And then it goes to training. What model? The best model that we have identified here, right? So single model, it goes through and it gets trained. This gives us the actual equation, the parameters or the coefficients. Using these parameters, we will pass new data for prediction. So we are not getting the complete data, right? Data is not getting exposed. Right? This is how the data security is implemented. Okay. We do masking, we do restricted access, we provide access only on authenticated users. Encryption of data happens. Right? So a lot of other security related aspects are implemented, Krishna. Correct? Yeah? Okay, wonderful. Okay. Okay, it's time. Do we have any questions? I will tomorrow talk about the deployment strategies. That means we are talking about MLOps concepts, again at a high level, on how the productionizing of our model is happening. What is concept of pipelining, right? What does MLOps standards means? And how do we ensure monitoring and maintenance is also implemented? Okay, at a high level, we will discuss this tomorrow. And I want you people to also bring up questions from ML side so that we can further discuss on those things in right tomorrow and day after tomorrow's class. And from Monday onwards, we will jump into neural network models.
And
Yeah.
how the sorry, yeah, please go ahead.
No, I was asking any questions. Go ahead.
Yeah, these things how we are, I mean, correlating to Gen AI, actually, it is my, I mean, just wanted to understand.
These are all foundations. If you remember
Okay.
yesterday, we talked about how AI evolved.
Yeah.
So we are looking at statistical models and practically how the statistical models are implemented.
Just to get an overall idea. I mean,
Yes, that's all. Because of this knowledge, we understood how we can improve the models.
right.
And from there, again, further improvement, right? So
Yeah.
from
Then we
that
can
perspective.
correlate to LLMs actually later point of time.
That's right. Yeah. Can you send the material PDF or something you can read, please? Okay. I can refer some books or I can probably give you PDFs which are there. They are publicly available. I'll pull some PDF and I'll share it with you. And I want you, I'll explain. I want you to learn how to use any of the LLMs for right getting the appropriate material for preparation purpose. So we'll look into the application of LLMs. Yes. How do we summarize the entire data?
Yeah, that is
How do we give prompts, etc.? We'll probably talk about that tomorrow.
that is going to be more, I mean, interesting.
Yes. You have to remind me, okay? Just remind me tomorrow so that right, we also do this.
Sure.
Okay. All right. So we'll stop here and I'll see you guys tomorrow.
Thank you,
Thank
sir.
you.
Yeah.